Hey guys, Ben here. This is a video to show a software that I developed for system integrators. It's called Gandalf because it's a Modbus Wizard. It's basically a Modbus playground and troubleshooting tool. It can do Modbus simulation, scan Modbus TCP, scan Modbus RTU, and it has an auto detection wizard which brute force serial settings when you don't know the baud rate, parity, stop bit, etc. So the software itself, when it opens up, by default it will open up on the Modbus simulation, and you can simulate from IP address that you select depending on your IPv4 settings, or you can do localhost. And about the IPv4 setting, I added here a button that it's like a nice to have, just directly opens your network adapter settings location, so you can quickly go into your network adapter and change your IPv4 settings to be on the required subnet. And then you can decide if you want to simulate function code 1, 2, 3 or 4. I normally go with my auto simulation demo, which simulates 70 types of 70 registers on different types, and the start and end address and the device ID, you need to set all of those up if you would like to set something else manually. And when you start the simulation, you can do an automatic simulation or a manual simulation. Automatic simulation, the values just automatically change and it picks up the clock time and everything. But if you do manual simulation, it will just be on 0, and then you can set the values yourself. For example, and simulation is running. Let's stop the simulation and start the automatic simulation. And then from the Modbus simulation, you can go to the Modbus TCP, and then make sure that you're on localhost or the IP address that you want to be on. The port is normally 502 on TCP, and the start and stop address for the registers that you wish to scan. And choose the data type or the function code type. In this case, we know it's holding registers, and you can change the 1 based addressing to 0 based addressing if you want, depending on the device that you're connecting to. You will see later in the Modbus RTU section that my slave device, the Arduino, is 1 based addressing, and the simulation is on 0 based addressing. This is the pulling rate, so how often it pulls for the new values. You hit connect, and you can also ping. So I added a ping button over here, which will pick up the host IP address, and we'll attempt to ping it. And this way you'll know if you're likely to be able to scan anything to begin with. If you're not on the same subnet, or you're not connected to, if you're not on the same subnet, you won't be able to connect to the device that you wish and get the registers. And without further ado, I'll start the scan or expand it a little bit. And you can see down here the values are shown as integer 16. So it's a 16 bits integer type, data type. You can change it to unsigned integer, and then you're not going to have the minuses, or int 32, which is a normal type of or a longer type of int, and then you can do an unsigned int, and then you can do int 64, which is a double long integer. And then we can set it as float. And when we set it as float, you see that most of the values are gibberish, besides the block of actual float real values that we have is not swapped. So the most significant bit is at the front and the least significant bit is at the back. And those correspond to the block of registers from 30 to 40. And if you look at my simulation from 30 to 40, those are programmed to simulate values of real with most significant bits. If I change the swap format, swap mode, this is a similar structure to a PostSoft card for those who are familiar. I can change that to a word swap, for instance, and then you'll see that now my registers are between the 20 and 30 range instead of the 30 and 40. Because in my simulation, this block, the first 10 block registers over here are simulating swapped rails. And I can do the same thing for my float 64. So float 64, you will see that I have 2 registers that are showing actual values, and the rest is gibberish, and that will correspond to the blocks down here. So I have 2 block of registers for normal double and 2 blocks of registers for swapped double, and in this instance the 40 and for like 40 to 48 is the swapped. Yes, the word swap. And then if I change it to none, you will see that now it's those 2 registers between 56 or 52 to 60. The other thing that I included in this scanner is the ability to show the registers is as normal decimals or in binary format or in hex, because sometimes you are after just a bit value in a word, or sometimes the vendor gives you addressing in hex, or you need the values in hex for some reason to be displayed. And the other thing is that you can show the addresses in hex as well, because sometimes you get from the OEM the list or the register's location in hex, and then you have to pull out the calculator, and it's quite annoying to do the conversion and see if you're in the right spot. So this just does it for you. You can stop the scan and then download the results. Let's call it 123 and save it in my downloads. I already have one from the previous time, but I'll just replace that. And I will go to my downloads folder and I will open my 123 CSV file, and you can see I have the results from the scan. And I'll go back here, carry on the simulation. I just want to scroll down and show you guys another thing that I've added. So one of the big benefits of using my tool over any other tool available is the unlimited scan range. That, or I wouldn't say unlimited because I haven't tested everything, but I've tested the really large ranges where other Modbus like ModScan and ModZim and other sort of softwares that are supposed to do a similar thing. If there is a register that is not defined in your scan range, the whole scan range kind of fails. And in my scanner, I can change it, let's say 150 even. And the registers that are not defined, they will just say undefined, and it will give me the error code as well, so that there is Modbus error codes. And it will just keep scanning as normal, but it will show me, well, actually those ones are undefined registers. And let's say there was a group of defined registers further down, and we can demonstrate that with our simulation. If you do a manual simulation, then those will be undefined, and then over here, let's say I have defined registers again, and then undefined, so it will pick those up. It's not going to break the scan. So this is one big thing. The other honorable mention that I've recently added is that you can add sessions. So in this case, I'm scanning holding registers, but let's say I want to scan coils. So I just click on a new session over here, and I click on coil status, click connect, and then I scan, and you will see that I'm only getting the booleans from the simulation for the coils that are changing on the top. So I only have 4 values over those that are changing, and the rest are zeros or ones, because they are much larger than one. You just get one. And yeah, you can do another session and do input registers, connect. Those one will just be the same as the holding registers, program them to be just a duplicate. And yeah, if you can close the sessions, and I'll move on to the biggest sell point, in my opinion, for this tool. I had a really large project in the Taranaki-based hospital where we had to connect to hundreds of RTU devices, and we didn't know the connection settings or parameters for those devices, and we spent quite a bit of time trying to figure out the actual device IDs, baud rate, parities, etc. So I created this auto detection wizard, which is essentially a brute force testing all the different parameters to create a handshake and a stable connection, and then it passes those parameters to my RTU scanner. So let's say I don't know the scan range or the ID range or the actual ID, but I know it's between 4 and 6, let's say. I don't know the baud rate. In this case I do know, and I'll show you guys in a bit. So those are the parameters, and it's 8 and 1 and 11,000, 115,200, and slave ID is 5, but I'm not going to give it all the parameters. I just want to make it a little bit faster, and then we're going to change up the parameters and do another scan for demonstration. So I will start the scan over here. It will show you the scan progress, and you will notice it goes over 100%. It's because we do a quick sample mode of sample size 3, and if it thinks that there is good likelihood of establishing a connection over here, then it will do a more thorough scan with actually testing individual registers and a better handshake. While we do that, we can go to our simulation over here, and let's say I want to change this range to do 1 to 20. Oh, what I should have done is another simulation range, another session for simulation, but don't think I have that included. So do that randomly. So those are integers simulating 20, and you can see here, if I connect, you'll see it's only now the first 20 registers, and then the bottom one's going to be undefined, and doesn't affect my scanning capabilities of the device. We are about to establish a connection, I believe. Now we are there we go. So it detected that we are on COM7 ID 5. The baud rate is 115,200, and even though it says odd for the parity, it still managed to establish a good connection with it. So it's already setting up the parameters, and it's connected, and if I hit start scan, you will see that I'm actually scanning the values for my Arduino slave over here. And I programmed the simulation on the slave to be very similar to the simulation of the TCP, and same type of blocks. So you'll see the top, I have the booleans, and then the integers, and then I got the reals. And so if I do float, you will see over here that it's between 20 and 30 range, and if I do swap float, I get it between the 30 to 40 range. I do believe that my RTU is 1 based. Yes, okay. See, now it's between 20 and 30, and if I do none, then it will go down here. That will be from 31 to 40. The combination of the registers in the previous 0 based addressing was still producing good real values, so we still had them displayed, but they were just like not the actual registers that we're simulating. And then if I do float 64, then you will see that I have the registers down here, the 53 to 60. I do word swap, and I'll have the two registers here, 41 to 48. And if you can look at the Arduino code, you will see that this is where I place the float doubles, the 50 range, 50 to 59. And the normal doubles are 41 to 50 basically. The last two registers are like the two registers afterwards are just buffer registers with zero value. And the same applies to the display of the UI, so you'll have to switch back to integer view, because float, you're not going to have values as binary for float or hex. It works for integers only, hex and binary obviously. And you can change the addressing as well to hex like we showed before. And at the bottom again, let's increase the scan range over here to show something. So at the bottom you will see that we have undefined registers, and tells you the Modbus code error and what it means. So this is a legal data address. There is actually no defined registers in my Arduino IDE for that range. And we can do another session just like the TCP for coils, since binary is or serial connection is you can only do one connection from end to end. It keeps that connection, just opens another session on that connection. That makes sense. And I can do that in coils. This is holding registers. I can do another session in discrete inputs. I can't remember if I included those or not. Yeah, so yeah, we do have discrete inputs. That's good. You can change the pulling rate if the scan range is too quick. You can change that. So every 2 seconds it will update. If you want to be able to observe the values for a bit longer before they change, you can change the pulling rate. And yeah, that's about it for this wizard. And it took me a long time to get to this point. I got a lot of feedback from my workmates and suggestions to improve, and this is the final product as of now, the end of 2025. And I hope you download this program and give it a try. Hey guys, this is just a quick follow-up. During the creation of the video I realized that I didn't have an option to show the address ranges when you're doing a Modbus simulation, and I've also expanded the simulation range, so it's not just a 70 register demo, it's actually 103 registers demo. And you can simulate like block of registers and simulate a gap between them. So let's say I do from 0 to 20, actually let's do normal first and you'll see. So I've added the different data types as well for the doubles and the floats, that you'll have a normal byte order, you have a swapped order, you have a byte swap, and you have a word and byte swap. And then if I do this and I stop simulation and I start simulation again, you'll see that I have a block of undefined registers here in between. And if I go to my simulation and I click connect and start, you will see that I have a block of undefined registers here in the middle. However, it carries on scanning without interruptions to the end of the range. And just to show you, let's swap this to float 64, and then let's do word swap, and that's the word swap. let's do byte swap. We have the byte swap down here. Word and byte swap, we got those down here. And the none might be, okay, so the none is here. So yeah, so now in the simulation itself, we included all the other data types. And we also included the address range, so you can scan different ranges in your or simulate different ranges in your model simulation. Yeah. So this wraps things up. If you have any questions or concerns or features you might want me to add in future versions, let me know down in the comments below. If you appreciate the video and you appreciate the tool, I'm gonna leave a link to buy me coffee. This tool will be available for free, but it did take me a long time to program the whole thing, and I kept doing more and more versions based on feedback from users. So it will be appreciated, but completely optional if you want. Anyway, that'll be all. So thanks for watching, and I'll see you guys in the next one. Cheers, bye.